This video is for topic 6.9, Hess's Law. The objectives for this topic are to represent a chemical or physical process as a sequence of steps, and then to explain the relationship between the enthalpy of a chemical or physical process and the sum of the enthalpies of the individual steps. So really what Hess's Law says is that if a reaction is the sum of two or more other reactions, the enthalpy of reaction for the overall process is the sum of the enthalpy reaction values for the individual reactions. So it's really, the total is just the sum of the parts. So if an overall reaction can be described in multiple steps or multiple pieces, you have to add all of those different pieces together, and that gets you your enthalpy of the overall reaction. Now, there are a couple of things to keep in mind when we do this. If we have to reverse a reaction in order to get certain intermediates to cancel out, that changes the sign of the reaction. So if it's positive and we have to reverse it, it turns it negative. So that goes back to what we know from earlier, is that the reverse reaction has the opposite sign for the change in enthalpy. And then if we need to multiply a reaction by a coefficient in order to get the proportions to work out so that intermediates will cancel, we also have to multiply the enthalpy by that coefficient as well. So here's our problem. It comes right out of our textbook. So it says, suppose you want to know the enthalpy change for the formation of methane, or CH4, from solid carbon as graphite and hydrogen gas. So this can't be measured in a laboratory because it's very, very slow. However, we can measure the enthalpy changes for the combustion of carbon, hydrogen, and methane. So we have three different equations. Equation 1 is solid carbon reacting with oxygen gas to form CO2. That has an enthalpy of reaction of negative 393.5 kilojoules per mole of reaction. Our second equation is hydrogen gas reacting with half a mole of oxygen gas to form liquid water, which has an enthalpy of reaction of negative 285.8 kilojoules per mole of reaction. And then our last one is methane gas, or CH4, reacting with 2 moles of oxygen gas to form carbon dioxide and 2 moles of liquid water. And that has an enthalpy of reaction of negative 890.3 kilojoules per mole of reaction. So the way I always like to start is you need to compare your overall reaction to what your individual steps say. So I need to keep my carbon as a reactant. I need to keep my hydrogen as a reactant, which means my first two equations can stay in that order because they have carbon and hydrogen as reactants. However, I need my methane as a product. So I'm going to flip equation 3 so that I'm going to reverse it. So that makes our methane gas as a product instead of a reactant. So I'm going to change the sign on that as well. So I'm going to lay all those out, and then I'm going to see how my different components cancel. Because if the coefficients don't match up, then I might need to make some adjustments. So here's my first reaction equation, and it's unchanged. It's going in that order because I need my carbon to stay as a reactant. And then my second equation, I'm going to put in as written because I also need my hydrogen as a reactant. Now, I want to point out that our overall reaction has 2 moles of hydrogen, and this reaction is the only one that has elemental hydrogen, which means we're probably going to have to multiply it by 2. So here's my original equation 3. We already talked about how, since we need the methane to be a product instead of a reactant, we're going to have to flip it. So I wrote the original first, and then I'm going to erase it. And then I'm going to reverse it. So I have 2 moles of water plus 1 mole of carbon dioxide gas, forming 1 mole of methane gas and 2 moles of oxygen gas. So instead of negative 890.3 kilojoules per mole, it's going to be positive 890.3 kilojoules. So now I'm going to multiply my second equation by 2 because that gets me 2 moles of hydrogen, 1 mole of oxygen gas, and 2 moles of liquid water, which means I'm also going to multiply my enthalpy by 2 as well. I'm going to go ahead and erase my original equation 2 just so that it's not confusing. Now we're going to treat our reaction arrows kind of like equal signs. And I have the same amount of oxygen on both sides, so they cancel out. I have the same amount of water on both sides of my reaction arrow, so they cancel. And same with my carbon dioxide, which leaves me exactly what I'm looking for in my overall reaction. So 1 mole of carbon with 2 moles of hydrogen gas forming 1 mole of methane gas. And then when I add up all my numbers, I get negative 74.8 kilojoules per mole of reaction.